Hi there. I wanted to put this together. This is actually a fourth video with just some examples related to how we put together the product rule, the quotient rule, and the chain rule all into one big package. So it's really just going to be two examples. And my first example, we're going to find the derivative of f of x is equal to x squared times, I've got a 3x cubed minus 4 all to the fourth power. Remember, I can rewrite that so I can see my smaller functions, because I have a smaller function right here and a smaller function right here. So I have two different ones there. Let me highlight them for you so that you can kind of see them. I have one function right here, and I have a second one that's all of this right here. Alrighty. So I'm going to rewrite this as an x squared times this quantity, this whole quantity, 3x cubed minus 4 all to the fourth power. All right, so let's start out. I have my two terms, so I'm going to create, I see a product rule happening here, so I'm thinking this is a product rule. All right, that's my thought. So I'm going to say that means u is equal to an x squared, and v is equal to a 3x cubed minus 4 all to the fourth power. If I take my derivative of u, it's equal to 2x. If I take my derivative of v, I look at it and go, oh wow, this looks like a chain rule. So now that I've thought about chain rule, let's evaluate this one a little bit separately real quick. Okay, so I have some function v that's equal to 3x cubed minus 4 all to the fourth power. If I was going to evaluate just that v, I'm thinking about what I would do first, and I would evaluate this innermost function. So I'm going to say I have a w that's equal to that 3x cubed minus 4. And I'm going to say my outermost function, the last thing I do to get my v, is going to be take a y equals w to the fourth. It's a really ugly y. It's bothering me, but we're going to leave it alone. All right, so remember this is the first thing I do, the innermost function. The second thing I do, the outermost function. So I'm going to flop back this way. I'm going to say that my derivative of my y term, which I really just need to change because it's driving me crazy. All right, there we go, that's better, is equal to 4w cubed. Again, I don't want to leave this in w's, everything's in x. All right, so I'm going to sub in. I'm going to say my derivative of y is equal to 4 times 3x cubed minus 4 all cubed. All right, I got that from right over here. All right, so I just took this w value and I popped it right in there. All right, if I look at my derivative of w, then I'm going to have a 9x squared. Remember that to use this chain rule, I just go straight across, and so I can find my v prime as being, right, let's see, 4 times 3x cubed minus 4 all cubed all times a 9x squared. So I'm going to write my v prime as being a 36x squared times 3x cubed minus 4 all cubed. Okay, this is the one I'm going to use when I actually do my multiplication here with my product rule. All right, so let's go back to our product rule. This is right here is my product rule. And I use the chain rule to get one of the derivatives for my product rule. Okay, I don't need to worry about this anymore. It's kind of cordoned off and I'm done with it. So if I want to find my derivative of f prime of x, remember I'm going to go this way across. And I'm going to say that means that 3x cubed minus 4 all to the fourth power times the 2x And then I'm going to add, because I'm multiplying the two smaller functions. So I'm going to flop up here and add, and then I'm going to come back down this way. I'm going to multiply these two together. The only thing I'm multiplying down here is that highlighted term. I'm going to have an x squared times my 36x squared times 3x to the third minus 4 all cubed. It's a really long line, I know that. Okay, so see where I got those from there. And in reality, let's pop little parentheses right around here, just so you can see that that this one and this one match up, my two highlighted ones here, and this term and this term match up there for that second cross there on a crisscross. So here I have, let's change back to a blue, 2x times 3x cubed minus 4 all to the fourth power. That term's not too messy. This one I'm going to multiply that x squared times the 36x squared. So I'm going to have a 36x to the fourth power all times that 3x cubed minus 4, and I'm going to cube that. I'm done with this at this point in time because I don't really want to multiply this cube or this fourth term out at all anymore. All right. If I was trying to set this equal to 0 or something, I'd probably factor out a 2x and also 3 of these terms right here. But I'm not doing that. I'm just kind of leave it there. Let's take another example, and this time let's look at a quotient rule. So let's go to a new page, and here I'm going to say, let's say I have a g of x that's equal to a 5x squared minus 2 over a 3x minus 1 cubed. All right, well here I can see that I have two smaller functions. It's a 5x squared minus 2, and I have this little function down here in the denominator. It's 3x minus 1 all cubed, and that's a little function in and of itself. So here I'm going to say that my u, remember that's my upper function, is 5x squared minus 2. My v here is equal to the 3x minus 1 cubed. My derivative of u is equal to 10x. That part's not too bad, right? Remember up here we were thinking quotient rule. Right here I get over to this part right here, and I'm seeing as I try to take the derivative of v, I'm seeing that I have a chain rule because I have an inner function and then I have an outer one. So I'm going to try and find my v prime, my derivative of v. So I have got chain rule. And so I'm going to go off to the side and I'm going to do my chain rule. So I'm going to define the innermost function. Here that innermost function is this. If I was trying to find my value just for v, I would pop it into that middle part first. So I'm going to say that my w is equal to 3x minus 1. I'm going to say my outermost function, y, is equal to w cubed. All right. Now remember that's because I do this first and do this second. I'm going to flip around. I'm going to take their derivatives. So my derivative of y is equal to 3w squared. If I put my x's back in, I find my derivative of y is equal to 3 times 3x minus 1 all squared. I'm done with that one because I have my derivative of y in terms of x. I'm going to find my derivative of w. Oops, I'm in the eraser. My derivative of w is just going to be 3. That means I'm ready now to go ahead and find my chain rule going across. That'll give me my v prime. So that means that if I write it down here, v prime is equal to, remember I'm multiplying these because they're a chain, 3 times 3x minus 1 squared. This whole quantity is that y prime, all times my 3. I can take these two 3's and I can multiply them together. So I'm going to get a v prime that's equal to 9 times 3x minus 1 squared. So I'm going to write that up here, 9 times 3x minus 1 squared. Let's get rid of my highlighting because it's not important anymore. I am done with the chain rule, so I'm going to cordon that off so that I'm not worrying about it and I don't see it. If I'm trying to find my derivative of g, now remember, I'm using the quotient rule here, all right? Remember that part. So remember, I have a quotient, so because there's this line right here, I'm going to subtract the terms as I go across. So here I'm going to go across here. I'm going to have, this is equal to my 3x minus 1 cubed, that's my v term, times 10x. I'm going to pop up here, I'm going to say minus instead of plus like I do on the product rule. Now I'm going to go down this way. I'm going to say 5x squared minus 2, all times that 9 times 3x minus 1. And I'm going to square that. And I'm going to move my little line over a little bit so that we have some room to see what we're doing here. All right. Now remember, I finished doing this part. Now I'm going to divide by v squared. So I'm going to divide this whole thing by my v squared was 3x minus 1 cubed. Now I'm going to square that. So if I clean up the top a little bit and I go back to blue, I'm going to have a, let's pop that 10x out front. I'm going to have a 10x times 3x minus 1 cubed minus, there should be an end parentheses here, 9, I'm just pulling my 9 out front, times 5x squared minus 2, and then times my 3x minus 1 squared. So that takes care of, the 9 is out front, it goes to here, my 5x squared goes to here, and my 3 goes to here, okay? So that takes care of all of those bits from that part. All of this is divided by a 3x minus 1 to the 6th power. Now I'm going to notice that I have a 3x minus 1 cubed here and a 3x minus 1 squared here. I don't see anything else I can factor out, but I want to reduce this a little bit. So I'm going to factor out a 3x minus 1 squared. I have a 3x minus 1 squared. So my first term is going to become a 10x times, I have one 3x minus 1 left there, minus 9 times my 5x squared minus 2, all over my 3x minus 1 to the 6th power. If I get rid of the ones on top, the 3x minus 1 terms, this one's going to become a 4. So I'm going to come out of there with something that looks like 10x times 3x minus 1 minus 9 times 5x squared minus 2 all over a 3x minus 1 all to the 4th power. I'm going to multiply through in the numerator there. I'm going to get a 30x squared. This is mostly because I'm seeing some x squared terms floating around. Minus a 10x. Now be careful here. I have a negative sign right in front of this 9 right here. Okay, so keep an eye on that negative sign. It's going to distribute into both of these terms. So I'm going to have a minus 45x squared. And then negative 9 times negative 2 is going to be a plus 18 all over a 3x minus 1 to the 4th power. Alright, so let's add those x squared terms. I'm going to have a negative 15x squared minus a 10x plus an 18 all over my 3x minus 1 to the 4th power. That's probably as far as I go. I don't see a whole lot more going there on top, and I would be done. So you can kind of see how we can use the product rule or the quotient rule, and we'll use the chain rule with it. You can see how it kind of works together and they go together. It obviously can get more complex than this. It can be easier than this. Um, but hopefully this helps you a little bit. So I thought I'd do this set of examples just so you can kind of see how we put all three of them together and they mesh and work well together. All right, so don't be afraid to do little things on the side like what we did right up here to do the chain rule to find my B prime. All right, so if you have any questions, be sure to let me know. Happy to help. I'm going to post some notes with this just so you can see them. And then hopefully you will have a better understanding of how to use the product rule, the quotient rule, and the chain rule. Have a great day. Bye-bye.